Good morning, everybody. So for math today, we are going to be talking about translation. Now, translation can mean putting something from one language into another language. That's not what we're doing today. Don't worry. For today, translation in math just means that we are sliding something in a space. Sliding something. That's it. Let's take a look at what that might actually mean. All right, so for a translation lesson today, I have stolen a couple of toys. I have a dinosaur toy. And if I am translating this toy, if I'm sliding it, then I'm going to take it and I'm going to slide it. Now I'm going to take this toy again and I'm going to slide it back that way. Oh, now I'm going to slide it up a bit. Now I'm going to slide it down and right. Okay, so in watching this and thinking that I'm kind of a crazy person and how on earth is this math, you'll notice that the dinosaur looks the same no matter where I put it. He looks the same here. He's got his, not if I move it, he's got his feet at the bottom, tail on the right, head up here. Move him over here. Same thing, feet are still on the bottom, tail still at the side, head still at the top. Move him down here. Still the same, feet are still bottom, head's at the top, tail on the right. I am not turning the dinosaur. Okay, a translation is not a turn. I'm keeping him in one direction. A translation is also not a flip. I'm not flipping him over. That's not what a translation is. All I'm doing is moving up, down, left, and right. Maybe you aren't very good with dinosaurs and you're like, that doesn't make any sense. So I have here a little truck that's trying to move on its own, so I can move him left. I can translate him right. I can translate him up. I can translate him down. I can do a combination to get him moved around. That is what a translation is. So this is the part of the movie where you all say, oh wow, Mrs. White, you are an amazing artist. You're so awesome. Go ahead, I'll wait. You can say all those things. Hey, Liam, I heard that. All right, so you have some grids in your math today. So I've just drawn a great big grid on a big piece of paper. And we're gonna move Mr. Dinosaur around the grid. So let's start him here. And I'm gonna start with his feet on this little point, okay? The points where the lines meet are really important, okay? So I'm gonna move Mr. Dinosaur 2 squares to the left. And how I'm going to do that is I'm going to keep using his feet because his feet are already lined up. And I'm going to move them 2 bumps to the left. So let's do that together. Ready? 1, 2. Okay, so his feet are still lined up with where the lines meet up. Okay, so I moved him 2 bumps. Now remember, we're not counting the spots where the lines cross. It's not 1, 2, 3. No. We're counting the bumps to get there. Okay, now I want to move Mr. Dinosaur up 2. Can I do that? Yeah. Okay, so I'm going to again say, okay, I'm going to watch his feet. 1, 2. There, perfectly. Okay, so I did the bumps. I did bump 1, bump 2. I moved Mr. Dinosaur up 2 spaces, 2 units up. That's what it looks like. Now I can move Mr. Dinosaur to the right and down. So what would happen if I moved him 3 to the right and 1 down? Where would he end up? You figure out where that's going to be on your computer screen. 3 right, 1 down. Okay? We're still watching his feet. Let's move him. Ready? So we got 1, 2, 3 to the right. Beautiful. And now 1 down. 1 bump down. That's where Mr. Dinosaur ends up. So he was here, and we moved him that way. Now, in your math today, you're not moving dinosaurs around, strangely enough. Instead, you're going to be moving around shapes. So let's see what happens when we move a shape around. So this shape is a rectangle, and I found it in my children's little pretend kitchen. This is like a little bun. It's a rectangle for our math class today. So in your math, you're using shapes, and the shapes usually actually will line up in all of the corners. But your job is to choose one corner, one spot that we're gonna watch it move. So I'm gonna choose this corner because it's right lined up beautifully. And I'm gonna ignore the rest of the shape right now. I'm gonna pretend this corner is the only thing that exists when I move it. Okay, I'm gonna move it one down. Ready? So go one down. Beautiful. This corner, the bottom left-hand corner, went one down. Now I'm gonna move it back one up. Awesome. Why, if I'm moving it one down, would this not be correct? Well, I haven't actually moved it a whole one. I've moved it almost, but not quite. And you know why I made that mistake? Because I was probably looking at this corner for a bit. So I need to move one vertex, and I need to move just that vertex. And then I will move my whole shape. All right, you are in your actual book today on page 157. You're going to be doing pretty few, but that's okay. They're pretty quick. So in number 1, you're going to count the squares to say how many units right the dot slides. Now remember, just like when we count on a number line or basically just a number line, you're going to be counting the bumps. You're not going to count the lines, okay? We start here. This is not 1, this is 0. 1, 2, 3, okay? So count the bumps. 1, 2, 3, 4. Right? I'm not going to give you the answer to C because I already gave the answer to the first two. In this one, you're doing the same thing as number 1, except you're moving left. Right? Now on this one, it tells you how many units and which direction you need to move the dot. So you're still moving it with the bumps. So 4 bumps to the right. 1, 2, 3, 4. Oops, I gave you another answer. It's like Christmas today. I'm giving you all the answers. Number 4, it's going to ask you how many units right and how many units down does the dot need to slide to get from A to B. So it needs to go this way and it needs to go that way. So count the bumps again. 1, 2, 3, 4 to the right, and then 1, 2 down. So that one was already given to you. You can figure out these other ones. Then you're going to come over to number 5. Number 5 is a lot like number 4, except that you are the one who has to draw the new dot. So start at this dot, and then you're going to go 4 units, 4 bumps to the right, bump, 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 2 up, bump, bump. Okay, so you can draw where the dot should be in all of these. Then you're going to move down to number 7, and remember when we're moving a shape that it is so important that the dot stays on the same vertex. So this same point on this shape, when you move it, the dot is still going to be on the exact same spot. It's not going to move over to this corner. It's not going to move to that corner. It's still going to be on this corner. So you're going to draw the shape on this new dot now with the vertex in the same spot. Then down in number 8, you're going to move this shape. Now, it has shown you in the first one where the dot is, so this one is as easy as redrawing the shape with the same vertex on that dot. In B, you're going to count and you're going to slide the dot 5 units left, so 5 bumps left. 1, 2, 3, 4, 5. Draw the dot to help you and then redraw the shape. Okay, same as C. And then finally, you're going to come over to number 10. 10 is the sort of trickiest one, and you'll see there's a gray box above 10 that gives you some step-by-step instructions. So if you're struggling, this one will explain it again for you. And you're going to move the dot 3 units up and 3 units right, and then 1 unit up. And then after you're done drawing that dot where it needs to go, you're going to draw the shape, making sure that the dot is in exactly the same spot. Now for these two, you'll notice there is no dot. You get to choose where the dot goes on the shape. So you choose any spot on the shape, on either shape, and then you're going to move that dot, what it tells you to move it, and then redraw the shape. The cool thing here, and you can even try this, is you can draw that dot on any vertex. It doesn't matter. And every time you move the shape, it will end up in the same spot. You can play around with that a little bit. Before I let you go, I'm a little bit sad that I only have this one picture to show you today, but it's a pretty awesome one and I really loved getting it. So here is Adam, and he's not just doing school, he is doing school in style. Now, Adam, I don't know what you think, but I think that you may have inspired our entire class. So next week, I would love it if you got yourself all dressed up as fancy as you can be in your own house and send me a picture of you in your super fancy outfits doing your work. That is your challenge for next week. I guess you could do it today too. Have a lot of fun. Have a wonderful weekend. I'll talk to you guys on Tuesday. Roar, roar. Ah, we all died. Roar, roar. Oh, wait, oh. Hi, guys. So you're gonna move your grid. Wait, you're not moving your grid. Oh man, I'm gonna have to start again.